So a very good afternoon to all. I welcome you all for this today's lecture of our subject industrial hydraulics and pneumatic. Okay, in the last last lecture we have discussed the hydraulic pump. Okay, that means the one of the basic element of the hydraulic system. Okay, and in the chapter number 1 we have discussed the actuator. Then in the chapter number 2 we have discussed the pump. Now let us discuss the another one important basic element of our this subject. Okay, that is a basic element of the hydraulic system, that is an accumulator. Okay, now the basic definition or the basic purpose of this accumulator is to store the hydraulic energy. Okay, what is the function of this element? Then one line answer is the to store the hydraulic energy in the form of pressurized fluid. That's it. Okay, nothing any innovative about this accumulator. Accumulator is the basic element of the hydraulic system, which is required to store the hydraulic energy in the form of pressurized fluid. Okay, now from where you will get this pressurized fluid? We know that from the hydraulic pump will get this pressurized fluid. That means the fluid which is provided by the pump, that will be the pressurized fluid, and that will be stored in a one compartment or in one reservoir, that is called the accumulator. Okay, and now what will do with that stored pressurized fluid? Okay, so whenever it is required or whenever it is required to provide that pressurized fluid, that time you can take that pressurized fluid from the accumulator. That means whenever we need, that time you can take from the pressurized fluid, you can take from that tank, that is called from that reservoir, that is mean the accumulator. Okay, so in simple words I can give the definition of this accumulator is that hydraulic accumulator is a device which is used to store the energy of a fluid which is in under pressure and make this energy available as a quickly secondary source of power. Okay, whenever it is required from the hydraulic machines or the other such hydraulic application like that, other hydraulic devices such as presses, hydraulic presses, lifts and cranes. Okay, whenever such devices required hydraulic pressurized fluid, no, that time from this reservoir, from this accumulator you can take. Okay, so to store the excess amount of hydraulic that pressurized fluid, for that purpose this unit is required. Getting it? Now here I will give one small example about this accumulator is that in case of now from in which application this accumulator is required. Okay, so for that purpose I will give one example that that is in case of hydraulic cranes or the lift. Okay, there the liquid which is under pressure, no, that needs to be supplied only during the upward motion, only during the upward motion, that we know that. Okay, upward motion means what? Upward motion of the load. So this energy, hydraulic energy, is supplied from the hydraulic accumulator only. Okay, but here one condition is that when the lift is moving downward, no, that time no large external energy is required, as we know that. And during that period of energy, when downward motion is there, no, that time that energy, hydraulic energy from the pump you will get. So that energy, hydraulic energy in the form of pressure liquid, that you need to store. So to store that hydraulic energy, we need one reservoir, and that reservoir means the accumulator. That is a simple basic function or purpose of this accumulator. Okay, so once again I will tell the basic definition of accumulator. Accumulators are the simple devices that store energy in the form of fluid, pressurized fluid under pressure. Okay, and whenever it is required or whenever it is needed for the device to use the pressurized fluid, that time you can take pressurized fluid from that reservoir or from that accumulator. Okay, now where this accumulator unit or element is it is used. So here I will give the some example like that. Hydraulic presses in that accumulator is required. Then construction equipments are there, farm machineries are there, power brakes are there. Then in the automobile industry, in that automobile suspensions are there. No, in that also we need the accumulator. Then in the ships, then landing gear mechanism on airplanes. In that sector also, in the hydraulic system, this accumulator element is required. Okay, so this is a basic examples of the basic examples of the accumulator where the accumulators are used. Getting it? So now we'll go for further, that is types of the accumulator. Okay, types of the accumulator, that means the classification of the accumulator by the means of how they use the energy storage. Okay, classified by the means they use for energy storage. Okay, so these accumulators are classified in terms of the manner in which load is applied. Okay, in the by which mean this load is applied. No, so based on that, here also classification of accumulator is there. Okay, so there are basically three types of accumulators are there. Okay, so which are used in the hydraulic system. So first is the weight loaded accumulator is there, then spring loaded accumulator is there, and gas loaded accumulator. Now further, this gas loaded accumulator is further divided into two groups. One is the without separator gas loaded accumulator, and with separator gas loaded accumulator. Then again further, without separator gas accumulator is divided classified into subtype, that is non-separator gas loaded accumulator. Okay, without separator or non-separator you can it. And under this with separator gas loader accumulator, now again in that three base subtypes are there. One is the bladder type with separator gas loader. Then we have the diaphragm type with separator gas loaded accumulator, and last one piston type with separator gas loaded accumulator. So these are the types of the accumulator, okay, which are classified by the means of use for energy storage. Okay, how that accumulators are used for the energy storage depend on that. That means how means the based on the based on in which load is applied. Okay, so these are the classification. Just to have a look. Okay, then one by one I will give explanation. Now whether my voice, my audio, my video is visible at your end, just tell me in the chat box. Then we'll go for the one by one. We'll see this one by one. In the chat box, please write down yes, no. Okay, accumulator is the basic elements of hydraulic system which is used to store pressurized fluid, okay, or hydraulic fluid which is under pressure. Okay, and whenever it is needed for the any device, hydraulic devices, that time you can provide the hydraulic fluid, pressurized hydraulic fluid from that accumulator. You can call hydraulic reservoir also, but whatever the stored fluid is there, no, that is in under pressure. That means the pressurized fluid is there. Getting it? And here we have seen the classification or the types of the accumulator. Okay, and this classification has been made depend on the use for energy storage or by the means of in which how that load is applied. Getting it? And depending on that, we'll go for the first, that is a weight loaded accumulator. Weight loaded accumulator. Okay. Now, for this weight loaded accumulator, no, we have the another name also, that is called dead weight loaded accumulator. Dead weight loaded accumulator. It's a figure I will share here. Okay, you can see this is a figure of weight loaded accumulator or dead weight loaded accumulator. Okay, now how it works, that we'll see. That means it's a construction and operation of this dead weight type of accumulator that I will explain with the help of this figure. Okay, so please have a look on this figure. Okay, so if you see the screen, no, if you see this figure, no, then we'll come to know that it consists of a piston rod. You can see the plunger, this one piston rod, this. Okay, please check my mouse is there, cursor. This is a piston rod. Okay, so this accumulated dead weight or weight loaded accumulated, it consists of a piston rod, or you can call it the ram or plunger loaded. Okay, with this dead weight. Now, where this dead weight is there, you can see the W. This is a dead weight. Okay, this is a plunger or the piston on which we have the dead weight. Getting it? Getting it? And this plunger will move within this cylinder. Getting it? So this is a cylinder. Okay, on inside this or within this cylinder, this plunger or the piston will move. Okay, so this plunger or piston is going to move within the cylinder. For why that piston or plunger will move? For because it will exert pressure on this hydraulic oil. Hydraulic oil. That means here, whatever the black is there, no black surface, in that portion you will have the hydraulic oil. That means the pressurized hydraulic oil. Okay, so when here excess amount of fluid will be there, no. Okay, here, okay, this is the inlet and outlet also. So here one wall will there. Okay, check wall. So whenever excess amount of fluid will be there, no, that time that excess amount of fluid will come inside this cylinder. That time, due to the pressure of this hydraulic oil, this plunger will move in upward direction. That means this tank, this cylinder will full with the help with that hydraulic oil. Now, and whenever the pressurized fluid is required, no, that time from this wall, from this port, this hydraulic oil will exit. Okay, and that time this due to the dead weight, okay, which is placed on this plunger of piston, that time due to that this fluid will goes through this port. Okay, and then it will goes to for further actuator or wherever it is required. Okay, so what are the fluid, excess fluid is going to come now from the pump side. Okay, so through the check wall, okay, whenever excess fluid is there, no, that time it will come under this accumulator. Okay, that means under this inside this or within this cylinder. And whenever for actuator, whenever pressure of fluid is required, no, that time this will come from this port. Getting it? Okay, so how it is going to come outside? So with the help due to the weight, dead weight, which is placed on this plunger or the piston. Getting it? So once again I will tell this operation. Okay, we come to know that it's a construction now. Okay, so in the beginning what happened, this ram or this plunger is there, no, so this will be at this lowest position. Getting it? This you can call or you can suppose as a lowest most position. Okay, now varying when idle position, idle period of during the idle period of the driven machine, no, okay, that means your actuator, suppose it is at a idle period of your that actuator. Okay, say that means a lift or that crane is there, no? So that time high pressure fluid or that oil, it is going to supply by the pump, getting by the pump, pressurized fluid is going to supply, and that is going to accumulate, or that is going to come inside this cylinder through this check wall. Here one check wall will be there. Okay, that time this plunger will move in upward direction, getting it? And when your actuator would start, no, that means when that upward or downward direct upward position want to, for example in the crane or the jack or press, so that time fluid is going to allow continuously from this port. Okay, that time this ram will come in downward direction. Okay, that means pressurized fluid is going to come outside, or it is going to exit from this port. That is a simple working operation of this weight loaded accumulator. Getting it? Now let me tell the some advantages of this dead weight type accumulator. So the advantages of this weight loaded type accumulators are: the first advantage is that the weight loaded accumulator produce constant pressure for the full stroke. Okay, that is until all fluid is sent out, no, up to that, this will produce constant pressure. Okay, this will produce constant pressure. Then another advantage is that they can supply larger volume of fluid under high pressure. Okay, this type of accumulator can supply larger volume of fluid under the high pressure. And the third advantage of this weight loaded type accumulator is that the large volume of the fluid makes them possible to supply pressure, okay, to several hydraulic circuit also. Okay, so where in many hydraulic circuit we need the large volume of fluid. Okay, so for that purpose this accumulator makes make to possible to supply that high pressure fluid for the hydraulic circuit. Getting it? Along with this advantages, we have some basic disadvantages also. So this weight loaded type of the accumulator are not often used in the modern hydraulic system because of the following points. Okay, I'm going to tell some point. Because of that only this weight loaded accumulator, it is not used in the modern machinery hydraulic system. Okay, so why it is not used in modern hydraulic system? Because they are actually this type of accumulators are normally very heavy and expensive. Then they are not portable, and they are this type of accumulators are not portable. Okay, and due to that only it cannot be used for mobile application. Mobile application means the movable devices. Then they also do not respond quickly to change in the system demand. Okay, so how if I will press one button quickly, I need some response. So from this type of okay, I was telling about the this type of weight loaded type of accumulator not giving quick response. Due to that only this type of accumulators are not used in modern hydraulic system. Okay, so this is about the weight loaded accumulator. Okay, understood or not? Please tell me in chat box. You can write yes, no, so that we'll go for in the next type of accumulator. All are requested to please respond me. Okay, I'm just asking to write yes, no in the chat box whether you understood this accumulator or not. Only few students are giving answer, that means yes, no. Other students, what are you doing? That I don't know. Okay, whether are you listening to me or not? Okay, so those who have given
answer for them, I would say thank you. Let us go for the another one type, that is another type, that is a spring loaded accumulator. So let us discuss this spring loaded type accumulator. Okay, and here I have shown the schematic sketch of the spring loaded accumulator. Okay, so what is the difference between the derivate type accumulator and spring loaded accumulator? If you see this schematic, then quickly you will realize that in the derivative loaded there, okay, on the piston there were the dead weight, and here spring is there. That means to give the load to the ram or that plunger or the piston, their dead weight was there, but here spring is there. So whenever hydraulic pump is going to supply pressurized fluid, so through the check wall you will get the fluid inside in this cylinder here, okay, in this tank, okay, from this port. That time this piston will move from this downward lowest most position to it will move in upward direction. That means spring is going to compress, getting it? Okay, jab fluid in from the downward direction, okay, from that port, then due to the pressurized fluid, okay, due to that pressure, piston will move in upward direction, okay, and that time spring is going to compress, getting it? Now that means your actuator or for the whatever the that system is there, system element, hydraulic system element is there, that is at our ideal position. That means it is not required hydraulic fluid, but your hydraulic pump is going to is supplying some fluid, okay, so that pressurized fluid, whatever the we are getting or whatever the supplied or provided by the pump, that is going to come inside this accumulator, okay, through this direction. You can see through this port, okay, and due to that pressurized fluid, this piston will move in upward direction and this tank will full. Now when your actuator will start, that means when your actuator is going to move in upward direction, that time actuator needed some pressurized fluid to apply the force for the upward direction. That time from this port or from this accumulator, this pressurized fluid is going to come outside and it will go through the your actuator unit, okay, and that time from the upward direction, the upward position, whatever your piston is there, at this position, okay, at upward, so due to the spring, load will apply, and that time this pressurized fluid is going to exert from this port, getting? That is the basic working principle of the spring loaded, okay. Once again I will repeat, when the fluid is discharged out of this accumulator, that means when your fluid is going to exit from this port, that time the hydraulic fluid, this pressure fluid is forced into this accumulator cylinder, okay, the sorry fluid is discharged from this port, that time that the spring to, okay, when that fluid is going to come outside, that time spring is going to expand, okay, getting it? So that is a basic principle working and operation of this spring loaded accumulator. Understood? Please reply me. Please reply yes, no. Understood or not? Other students, please reply. Everyone, please. Okay, so this is about the spring loaded. Okay, dead weight accumulator and spring loaded accumulator, both are similar to each other, just replaced by that dead weight by this spring. Okay, let us go for another one. Now we'll go for before that one point is remaining, that is the advantages of this dead weight. Sorry, advantages of spring loaded. 1 minute. Uh, about this spring loaded type accumulator, I wanted to tell about the advantages also. So the first advantage is that the spring loaded accumulators are usually smaller and less expensive. Okay, so than your dead weight type accumulator. And another advantages is that they are easy to maintain. Okay, but along with these advantages, we have the one disadvantage, that the what is the pressure is done also, that pressure exerted uh, uh, by the fluid is on that fluid, no. Okay, of the pressure exerted by the fluid is not constant. Okay, because we know that what are the pressure uh, of the fluid in the dead weight is, that is constant, but here it is not constant. Getting it? Now let us go for next one, gas loaded. Okay, as I have discussed that types, I will show. Okay, we have discussed the weight loaded, spring loaded. Now we'll go for gas loaded. Okay, so the basic question arises that what are the gas loaded accumulators? Okay, so now normally for this gas loaded accumulator, there is one popular name also is there. It is called hydro-pneumatic accumulator, because this is a hydraulic accumulator, but it is a gas loaded. That means the gas means the pneumatic. So hydro-pneumatic accumulator it is called. Gas loaded accumulators means the hydro-pneumatic accumulators, and these gas loaded accumulators are most commonly used accumulators. Okay, these are the most commonly used accumulators are there. Okay, so due to that only gas and your fuel hydro-pneumatic. Okay, so due to that only hydro-pneumatic accumulators. One minute. Okay, so gas loaded accumulator. So this gas load accumulators, they work on the basis of our Boyle's law. Okay, Boyle's gas law. Okay, that means the Boyle's gas law. It states that for a constant temperature process, as we know that for a constant temperature process, pressure of the gas, it varies universally. Okay, with its volume. Pressure of the gas is varies universally with its volume. म्हणजे means what? P is inversely proportional to V. P is inversely proportional to V. P is inversely proportional to V. That time T is constant, temperature is constant. That is called the Boyle's gas law. Okay. Again, this gas loaded. Okay. As I have mentioned that this type of gas loaded accumulators are mostly commonly used accumulators in almost all the industry application. Gas loaded accumulators. Okay. Now for this gas loaded accumulators also we have the two types of gas loaded accumulator. One is the, as I have told that without separator, that is called non-separator type, and separator type gas loaded. It is called with separator. Okay, and this separator type or with separator gas loaded type accumulator also divided into the three types. One is the bladder type, diaphragm type, piston type. Okay, so let us go for this without separator or non-separator gas loaded. Okay. One minute. This one. Okay. So this is a non-separator type gas loaded accumulator. Okay. So this figure shows the diagram of our non-separator pneumatic loaded. Means what? Non-separated gas loaded accumulator. Okay. Which is used in many hydraulic circuit. Okay, and in many industrial application purpose, this type of non-separator type accumulator is used. Okay, this non-separator gas loaded type accumulator, and it consists of a fully enclosed cell. You can see we have this fully enclosed cell. This. Okay, this is a cell. Fully enclosed cell is there, and it contains the gas. Here we have the pressure gas, you can check, and here we have the gas charging type. Gas charging type. Okay, or we can call gas charging. Charging means what? To take inside. Okay, to take inside. It is called gas charging tab or gas charging wall, you can call. Okay, on the top we have the gas charging tab or wall, and we have the oil port also on this bottom. We have the oil port. Here from this you will get the our hydraulic fluid inside, and it will come outside. This still casing is there. Okay, this enclosed cell is there. Okay. Now when from this gas charging wall you will get the pressurized gas inside. Okay. Now this gas actually it confines at the top only. Okay, it confines at a top only, and the oil remains at this bottom only. Okay, and there is no physical separate between them. Okay, actually there is no separate. Okay, because gas is separate is there, and you'll get the fuel from the bottom. Okay, so without, it is called non-separator type gas accumulator. Okay, gas is there, fluid is there. There is no any separate partition in between that. Okay, gas pressure, what are the pressure gas is there, no, that will exert force on this hydraulic fluid. Okay, so due to that only, that means here gas, it has a direct contact with this oil or hydraulic fluid. Getting it? So due to that only, this type of hydraulic accumulator, it is called non-separator type gas loaded accumulator. Okay, when fluid is excess fluid, so this is going to provided by the actuator, no, sorry, pump, no. When it is going to come inside, no, that time it will full of this cell is going to full with the by this hydraulic fluid. And when actuator needs pressurized fluid, hydraulic fluid, that time gas is going to come inside this to through this tap inside this port or this cylinder, or you can call cell. That time gas pressure of gas is going to apply the pressure, and due to that pressure hydraulic fluid is going to come outside this port. That is the basic working principle and operation of this non-separate type gas fluid. Okay, once again I will repeat. In this type of non-separator type gas fluid accumulator, pressurization is achieved by introducing this pressurizing gas, okay, into this container, okay, above this gas level. Okay, and when system pressure increases, no, okay, when system pressure is going to increase, no, that time oil enters through this pore, okay, and it pushes this gas in upward direction. Okay, and that reduction of the gas is going to volume of the gas increases the pressure. We know that it increases the pressure, and this gas pressure is used as a potential energy for our purpose to for this oil. Okay, when it is required in the circuit of that time, due to the pressurized gas, due to the pressurized gas, it is going to exert force on the hydraulic fluid, and due to that only hydraulic fluid will come outside this port, and it will goes further to the your hydraulic circuit. Getting it? Now, advantage of this type of accumulator is that the this non-separated type accumulator, no, it can handle large volume of oil. Okay, but disadvantage is that due to the absence of the separator in between the your pressurized gas and hydraulic fluid, no. So due to that only the gas is going to absorb by this oil. Okay, and it is also entrapped into this oil. Okay, so this type of accumulator is not preferred for use with high speed pumps. Okay, because the gas is going to entrap in the oil. Okay, and that may cause the cavitation and the damage in the pump only. Okay, so due to that only it is not used more with high speed pump. Then we'll have the another one. Now this is about the non-separate type. We'll go for the separator. Now this is the first type of separator gas loaded accumulator, and this is a bladder type gas accumulator. Bladder type separator accumulator, gas loaded accumulator, bladder type accumulator. Okay, so based on the barrier used, okay, that means the separator used, no. So separator type accumulator can be classified into three types. Okay, based on the barrier used. Okay, that means the separator used, no. So based on that only separator type accumulators are classified into three types. One is the bladder type, second is the diaphragm type, third is the piston type. Okay, and this is a bladder type accumulator. Okay, so the construction and operation of this type of bladder type accumulator, no. So that I will explain with the help of this figure. You can see. So if you see this figure, no, then you will come to know that it consists of a bag. It consists of a bag. You can see this bag, or you can call it as a bladder. Okay, it is called gas charged. Bladder means one is a bag. It consists of bag or the bladder of a synthetic material. Okay, the material of the bladder is a synthetic material which is pre-charged, already charged with the gas to a determined pressure. Okay, already this bladder is charged with a predetermined pressure, and this bladder is placed within this accumulator. This is called accumulator. We know that it's having the steel casing cell. Okay, here we have the oil valve. Okay, oil valve from this port it is going to come inside. Here we have the protection tab, gas wall assembly. Here from this gas is going to come inside this bladder or inside this bag. Okay. So this bladder is called the separator. Okay. So this bladder is placed within this accumulator cell, and balance of this space fitted. Sorry. Actually, the balance of this space, no, this space, it is actually filled with the oil. Okay, so oil will come, hydraulic oil or hydraulic fuel will come through this oil assembly. Okay, see, and when oil will come, that time this bladder is going to compress, and when it is required for the hydraulic circuit, that time bladder is going to apply pressure on your hydraulic oil, and that time through the oil wall assembly, hydraulic fluid is going to go outside. Okay, so that is a function of the that. Then we'll have the another one. Okay, you can see also working of the bladder here I have shown. In the normal position, bladder will be like this. Okay, and when the accumulator is charged, that means when hydraulic oil is going to come inside that cell, no, that time bladder you can see how it take a position. Okay, and when accumulator is discharged, that means when hydraulic oil is required for the hydraulic circuit, no, that time hydraulic oil is going to go outside this container. That time your accumulator will take position like this. So these are the working of bladder type accumulator. Understood or not? Please tell me, understood or not? Understood or not? Understood or not? Please reply me. All are requested to please. Okay. You reply yes, no. Okay, this is a bladder type separator accumulator, gas loaded accumulator. Let us go for another one. We'll have the piston type. Okay, piston type. So the construction and operation of this type of piston type gas loaded accumulator is illustrated with the help of this figure. Okay, one of the figures I have shown, I have taken also all figures I have taken from the hydraulics and pneumatic book by Ilyas Khan. Okay. Okay, to get basic or to get clear-cut knowledge and information about this subject, that hydraulics and pneumatic by Ilyas Khan, that book is very good. Okay, so I will explain the operation of this piston type accumulator. So as I have shown in the figure, no, so this piston, it serves as a barrier between. What are the piston is there, no? You can see here we'll have the port. Okay, from this port oil will come and I will go. Oil will come through this port, as well as oil will go outside of this port. Okay, and here we'll have the piston. Okay, getting it? When oil will come inside this cylinder or cell, that time this piston will move in upward direction and it will pack here. Okay, here. So as I have shown in this figure, this piston will serve as a barrier between your gas and oil. Here we'll have the gas. No, this another compartment is there. No, that is inside that we'll have the gas. Okay, and here also. Okay, so this piston will act as a barrier or separator between your oil and gas. Getting it? And this gas is order gas is there here, white you can see. So that gas is compressed when charged, no, and that time when hydraulic oil is going to come inside, no, that time this gas is going to compress. Okay, and that time your volume is going to compress. Okay, and this gas is compressed when charged oil pushes this piston against it, no, that time. And this gas pressure is used. What are the pressures? Gas is there, no? So its pressure is used for as a potential energy. Okay, and that potential energy of the gas is going to apply force on your hydraulic oil, and due to that only your hydraulic oil under pressure it will come outside of this portion. Okay, so that is a piston type accumulator. Now you can see how these accumulators are used. This is a hydraulic circuit. That means this accumulator is there. Here we have the wall. Okay, a wall. It's a hydraulic symbol is here. Okay, it is used. This is a symbol of the accumulator. Here you can see this is a wall, and this is a system. This is our double acting cylinder. Okay, that is actuator. Here wall is there. Okay, check wall. Okay, so this accumulator which is used as a secondary source of energy. Okay, whenever pressurized energy means what, that hydraulic energy. Okay, this is one circuit where accumulator is used. You can see. Then I will show another one here also. This is one of another circuit, hydraulic circuit, and you can see here we have the accumulator. I will show another one here also. Here accumulator is used as a fluid makeup device. Okay, fluid makeup device means what? For example, we need 100 psi pressure, and for suppose we'll get 80 psi pressure from the fluid which is going to come from the hydraulic pump. Now remaining 20 psi you can take from the accumulator. It is called the makeup. Okay, you can see the where accumulator is used. Okay, this is the circuit diagram of the hydro. That means gas loaded wheel suspension system. Hydropneumatic means the gas loaded wheel suspension. Okay, here we have the wheel and the suspension. So you can see the circuit, and here accumulator is used. Getting it? So this is about the accumulator. Now for better understanding, I will show one small video, and in the next lecture we'll see another one element, that is the intensifier. Okay, wait, I will share my screen.
Hi, Professor Vishal Taylor. Welcome to my YouTube channels. In this video, I teach you hydraulic accumulator is used to store the energy.
No,
Okay. So every energy is in.
I will show you the video. whether voice of video is not audible. 1 minute. Yes. I will show the working of. You can see how the from where you will get the fluid inside your accumulator and the spring loaded. I will show another one. This dead weight loaded. I will show the spring loaded also. Okay, I will start the working of spring loaded accumulator. Which type of walls are used? So about the wall we are going to discuss after one lecture. Okay, so we have in detail about the wall. It's a spring loaded accumulator. Last one I will show. Sorry, gas loader also we have. It's a gas loaded. So with this animated video, it is easy to realize the working of any device or any element. It's a non-separator type. Huh? Non-separated type. Understood or not? Please tell me in the chat box. Are you getting or not? The spring loaded. Now I will show piston type. Please tell me in the chat box. Huh? I will show now. Piston loaded. That's a piston type accumulator. Again, it works on please see how this piston type of accumulator works. Okay, so it's about the accumulator. In the next lecture, we'll see the intensifier and then we'll start the one. Whatever the actuator, whatever the pumps we have seen, so as a hydraulic part, no, the same will be as a pneumatic also. Okay, that time also we'll repeat. So thank you very much. Okay, please write down your roll number in the chat box. Okay, as a your attendance.
Thank you, sir.
Okay, see you tomorrow. All are requested to write your roll number in the chat box.